in the chat. Oh God. I don't mean that chat. I mean this chat. I don't think I read all that. Oh, what? Rush is crashing. Oh yeah, I did read that. Oh, and my board is coming out really well. Actually, I've drilled the board. I've actually drilled the board. Yeah, I managed to get my collet working true. I ordered some new collets, and they should be in about what? About a week, maybe less. But I wanted to do this board because actually I'll tell you why. I ordered some more circuit boards, another 5, and guess what? Because I never noticed this before, but you know why this board was always slightly undersized? I couldn't figure out why the transfers kept going off the edge of the board. I thought, well, that's strange, because I got the sizes right on my program. My program is supposedly accurate, and I thought I'd got the dimensions right. And I couldn't understand why the board size let's see, size 200 by 595, right? Hang on, let's look at this at the bottom. I'll show you what I mean. You can't see it because it's too small. At the very bottom it says size 200 by 595. Well, when I measure these boards, they're actually 100 millimeters. Well, I think that's actually, I don't know if that's measuring half sizes or what. Well, anyway, it's 100 millimeters long. It's supposed to be. Is it 70 millimeters wide or something? Anyway, it's not. It's 59 millimeters wide. So these boards were actually undersized. They were a millimeter undersized. That's why a millimeter of my transfers wasn't making it onto the board. That explains a lot. Anyway, the new boards I ordered. Oh dear, I've knocked the camera. I bet. Let me see. I've really messed it up. Oh, it's still. Yeah. I should be on camera actually. These new boards I ordered. Guess what? $70 millimeters by 100 millimeters, right? That's what it says on the label. Well, they're actually bigger than my boards that I've been using, which is what I want. So, when I hold that board up against that label, you can actually see that the new boards are actually a little bit bigger. Yeah, great, fantastic. I won't have that problem anymore with my transfers running off the edge, because they actually are the same size, except for the fact that the new boards, these new batch that I've ordered, are 70 millimeters. Now when I put that board on top and get it the edge straight on one end, I noticed immediately that there's an extra millimeter on the edge there. Don't know if you can see that. Light's in the wrong place as usual, but there is an extra millimeter on this new board that I ordered. There's my nails over the edge of the new boards. So yeah, I want to make another one, but I'm not going to populate this board actually. I'm just going to do another board. I want to keep this one as a reference because it's yeah, it looks cool, and I want to hopefully well, there's nothing wrong with this board, it's just that this one doesn't have the switch position on it, and it's still worthwhile as a spare board if I need to build an extra one later on, you know. But I've drilled it anyway, and there was a slight glitch I found on it. There are two tracks shorting out, but no, next to the IC, it's pin, hang on, is it pin, hang on, I've forgotten which pin number it is now. 7, 8, 9, 10, 11, 12. Pin 11 and pin 12, actually there's a short actually between those two pins, but yeah, okay, I could cut that easy, no problem. Well, what I did was, I took the, instead of messing about with the copper board, because that pin's not used anyway, I took the pin out of the IC socket, right, which is good because those are the compensation pins. That pin and that pin is compensation, and compensation was actually shorted out to one of the other pins, so yeah, I just took the sockets out of the IC socket, the extra slots out there, and so that solved the problem. But actually now I really feel like I want to etch a new board because these are a little bit wider. Anyway, there's 5 in there and they were cheap. They were like, what was it, £2, £3 or something. So it wasn't expensive. And I'm not going to waste a board, I'm just going to, yeah, it's handy. In case I need an extra one. I'm not worried about that short there because I know about it anyway. But I can certainly put that. I can certainly solve that problem with my my little cutting disc. I can just go around it. I can just go to that where it's joined and just that bit out. I might actually do that actually, just so in case I do forget. And decide to use it later and then find out there's a short and wonder why. It's just the compensation pin is actually connected to. I've since rectified that in my software. So I don't know if you are watching Hyde. It's probably a bit early. You probably don't listen to me first thing in the morning. Probably simulated hangover. But yeah, the pins that were causing me the problem was, I'll show you which one it was. It was this pin which was actually shorting across, oh you can't see now. Right, it was this pin which is highlighted white that was actually shorting out with this pin. But this pin is not used, you see, because it's compensate. Oh, you are watching me. God, you're brave. Yeah, I have. I fixed it. I've actually fixed it on the design. I've sorted that track out. This track was this track here. This one. No. This little angled one here was a little bit too close to this pin, and it caused them to become conjoined. But anyway, I fixed that now on the actual design. But yeah, I am gonna fix the board as well because I might forget about it. So what I'm gonna do is I'm gonna take this I'm going to take this, I'll go back to the camera, just a minute, take this thing out. Where's my flipping thing? I've got the wrong one. I've got magnets, and everything's stuck together with magnets. I've got some new collets coming. I ordered them today. I also ordered the switches. Anyway, I managed to sort my collet out, but it's not perfect, but it still works. It works anyway. That's the main thing. It's a bit wobbly, but it's not as wobbly as it was. Right, I need to take this chuck collet out because I have to put the big collet in for the diamond cutter, because that's going to make a lot neater job. Just a minute. Hang on a minute. I've got all these copper boards under here. I need to put them back in this paper for now. Still, I would be I'm eager to do another board, just for the sake of making sure that my perfected technique works every time, you see, and it's not going to be wasted. Anything that I don't use, I can make a necklace out of and give it to my daughter. She'll wear it. Well, my daughter Joanna, she's very retro. She'll wear anything that looks really odd and, what's the word, goth like, because my youngest daughter, she's very goth, you know. She likes black nail varnish and I'll just tell her that the circuit board is evil and then she'll wear it. I don't know, kids today, I just don't know, I can't work them out. Right, where the heck is my thing? Oh, there it is. Right, this is my other collet. I need to put that one in. I'll put chat back up because I can't see it right now. Oh yeah, I could cut it with a trace, but knives make a mess. I've done it with a knife before, but trust me, this diamond cutter, I'm going to do it in the magnifying glass so you can't even tell. I'm going to use my magnifying glass and very gently just grind the little join away from that pin. I've tightened it too much now. I keep forgetting that plastic thing's in there and it makes it tighten really quick. Still too tight. Right, I've got that in. Yeah, I used to cut the tracks with a knife all the time, but it always leaves a scar, right? You end up with a little scar, and I think I can do it better with this little wheel. And I need to put the wheel on very low power so it's spinning slowly, and that's what I'm going to do. I'm going to make it spin at about 3 volts so it's running very slowly. So, oh, that's way too fast. Just a minute, let me turn this down a bit. Alright, I'll see what speed that is. That's pretty slow, so it gets slower. That is... oh, that's as slow as I can get it. That is so slow you can't even hear it. I think I'm on 3 volts right now. Let's get my preview window up. Right, I have to find the track. Yeah, I can see it. It's right there. Oh, actually the camera wants to move a bit more. Well, I need the magnifying glass, so I don't make any mistakes, and plus it'll keep shit out my eyes. But this is going so slowly. It's working. Yeah, that's good enough. I had to stay away from that other track, you see. I'll show you what it's come out like under the magnifying glass. Let me just dust it off a bit. And there's no burrs because my cloth will be sticking to them. It's actually come out pretty well as that. So you'll be able to see the little cut where I did it. You should be able to see that. Well, it has left a bit of a scar, but it's not a burry, messy looking. It will fill in. It's when I put some polish on there, you won't be able to see it. I've basically just cut the bit where it's connected to that pin. I'll see if I can magnify it a bit more. Right, that should be clear. Yeah, can you see that hide? Yeah, a lot tidier than using a knife, that's for sure. Anyway, I'm just going to get a bit of polish. See, there's always something. You know, I went over that board with it like a, on my computer software. I went looking at it very closely, but I still didn't see that error. It wasn't until afterwards that I spotted it. That's what happens, you see. And now I've corrected it. I've corrected it actually on the software side. Now I've put a bit of polish on it. And I've already drilled this board, so right. Actually, you can still see the little thing where the wheel was, but it's nothing. It's not a problem. This is actually, I thought it was Paxlin, but it's not. It's fiberglass. It's actually fiberglass, so you can bend it quite a bit and it won't break. You see what I mean? You can bend it. It doesn't snap. It's pretty strong stuff, this fiberglass. And I wanted to test this while I was doing all this drilling and working on it, and absolutely none of my toners come off. Right, I mean, it's had a bit of abuse because I got burrs on the back and I had to scrape them off on my fingernail. None of the toners come off. So it's definitely resilient. It could take a few knocks. Quite a few knocks actually. Some of the holes have got clogged up again. I have to keep poking they got clogged up with polish, you see. The polish has gone in the holes. So I just get a resistor. Just get this other resistor and poke the holes out. Just to clean the gunk out, because they keep filling up with polish. That's it. Some of the others are bunged up as well. It's because I've just waxed it again. I put a bit of wax on there. But I thought, well, I can either build this board now, I've drilled it, or I can make another one. And I'm thinking about making another one, to be honest. I've ordered some new I've ordered them switches, so they're going to be in a few days. I'm not in a rush. I'm not in a rush to build this board, really. It'll be nice to get a board that's got the switch position ready on it. Okay. Alright, I need a ciggy as well. Actually, there's another 2 holes I haven't drilled yet. There's 2 holes I haven't drilled there, and that's with a tiny drill. So I'll wait until they come back. I have to get the drill centered anyway, so let's see. Find a nice small drill. I think it's on here somewhere. I'm going to use my tiny little drill. I'm going to see if that one fits. I want to see if the 0.3mm one will fit now without wobbling. Probably going to have to speed the thing up again in a bit. Well, actually, the slow speed is good for testing the wobble, actually. I've got the wrong glasses on, I can't see very well. That's better. I can see now. I need to pick one of these drawers out because I want to try one of these new drawers I ordered. I want to see if this 0.3mm one will fit. Well, I've got to take some slack up first. Ooh, feels like it's going in. Oh. Is it going to wobble on me? Hey, it's not bad, actually. Hey, it's not bad at all. Tighten that a bit more. You know what, this 0.3mm drill actually isn't bad at all. I need to get the speed back up again. Ugh. Right. Right, I'll wait till he come back. At least I can get my 0.3mm drills in there now. I wonder if you can see that. Can you see that 0.3mm drill bit? If you're back, I don't know if you're back yet. Look at the size of that thing. Look at the size of that thing. Oh my god. And I've actually got it running through as well. Anyway, I'll show you when you come back. Alright, I'll just... Okay, hi. I'm just going to add something to it. This board. I want to drill that 0.3mm drill bit hole. I just wanted to add something on here because I need to mark the heatsink slot on the top side of the board, which is somewhere around about. I think it's near that capacitor, I think. Anyway, I'll see when I actually add it on, because it's what's the word, transparent on here. So I need to add a shape, rectangle, so it's actually there. I need to cancel, escape. I need to get that text, properties, I need to copy that, heatsink mount, and actually paste it on the top silk screen as well. So add text. Oh, where did you put that that shape? Oh, it's in the wrong place. That shape wants to be on the top silk screen. Oh, it is on the top silk screen. Oh, well, that's alright then. Right, add text, top silk screen, heatsink mount, and that goes right in that box there. Now I should see it on the 3D now. Refresh. Oh, it's right next to that capacitor. It's actually kind of under. Mind you, the capacitors I'm fitting are actually a bit smaller than. They're actually a bit smaller than what they're showing on here. The heatsink doesn't have to be mounted. That means I need to move that capacitor a bit though, really. If I can. Let's have a look. Yeah, I can move it. I can move it a bit. I need to move this though. Hang on. Right, so I've moved that. Now if I grab the capacitor, it's currently fixed, so I need to unfix it. I need to just nudge that up a bit because I've got room. Let's just see, I need to move the bottom of this as well. Oh, hang on. Move that. That's fixed too. I'll probably have to redo these. Anyway, I don't know. I need to unfix them, really. Well, I'm probably going to refill this area anyway. I just want to see if that's far enough. Refresh. Oh, it's already refreshed that. It's moved it up a bit anyway. Tell you what, I've got a better idea. I'm just going to get rid of that ground plane and put it back again, and it's just a bit of tweaking about, but I'll just get rid of this a minute, just delete that. And put it back in a minute. I need to move that up a bit more. As long as I don't come too close to that, I'll just make sure there's no errors. Design rules check. I have got an error. It's oh, that's the gap in the net. That's nothing. I'm going to fix that in a minute. Oh, so that's okay. Let me just see where that is. I think that's good enough actually, because that heatsink is very thin. looking down the board. Hang on, let's just move this over. I need to look. Hang on a minute. Basically, I need to put my eye right on the edge of the board. Oops, too far. I think that's enough clearance for the heatsink between those, because the heatsink's going to run between those two transistors, which tip 42C and tip 41C. And I think there's enough clearance between there and the capacitor. I think that's good enough. Because that diode is connected to ground, by the way. So it doesn't matter if the heatsink comes into contact with that diode leg, because it is ground. It will be when I put the ground plane back. Actually, the ground plane's still there on that side. Right, so I'm going to put that other ground plane back, the one that's disappeared. Right, that's ground, that's not volt. So zoom out a bit. I've got the wrong glasses on again. Oh, bloody hell. Swapping from glasses to glasses. I'll drill that hole in a minute. I'm not in a rush. Right, I need to fill that back in. So pour copper, not volt. Okay, right, we'll fill the copper back in. Now I need to get rid of some of it, because some of it is actually I need to disconnect from the net. Disconnect from the net. That's not connected to the net. That's not connected. Oh, can't get it. This isn't connected to the net. The net is a connection, by the way. Yeah, I've just read what you said about the diode. No, the diode's connected to ground. The heatsink's also connected to ground, so it doesn't matter. The diode is connected to ground. Look, there. It's 0 volt. Everything that's highlighted in blue is ground. Everything that's bright blue is ground. And there are some things on here which aren't supposed to be ground, which are blue as well, which I'm disconnecting right now. Let's see about this piece. That's not. So that's no longer grounded. That is. Let's see. That doesn't need to be. Right. So that's no longer ground. This chunk here doesn't need to be ground. It's, when I fill the copper in, it tends to connect stuff, it makes it all ground, you see, until I go around and fix it. Oh, this little piece here doesn't want to be ground either. If I'm getting zoom in enough. This little chunk here doesn't want to be either. I can't get it. There we go. No, that doesn't want to be ground either. The rest of it, that does want to be ground. Let's have a look, see what else is missing. Oh, I lost a connection on there. Oh, that doesn't want to be either. Okay, I need to put another track back in. I've lost a track. Add track. Alright, that's back. Alright. Now the error check should pass now. Oh, I've got a shape error. Uh-oh, where's that? Go to error. Oh, it's up here. Oh yes, I've had that problem before. That piece can come out. Right, that doesn't have to be there. Right, it should be good now. Okay, no errors. Everything's good now. Good thing about this program, it tells you if you've got an obstacle, something that's not connected on the net too close, or to something on the net that's not connected. So there's a lot of things that don't need to be connected, like the ground plane, and that's why the purple areas are what it filled in for me, which don't have to be connected to ground. So I've just basically disconnected them, so I don't get the error saying it needs to be grounded, because it doesn't. They're just heat dispersal bits of copper, really, is what I'm putting up there to help. It doesn't even get warm, but if it does get warm, I just need a bit of copper there, you know what I mean? Right, so let me just check now the 3D. There we go. So the heatsink mount, which shows up there on the copper, that tells me where I can drill a hole and put a tab through there to connect to the heatsink. Well, that should be mirrored on the other side of the board now. There we go, it's there as well, look. So I can make a hole. It just gives me it makes it easier, as long as I get my silk screen on straight, it makes it a lot easier to know where to drill a hole. And I've also got one down here, a bigger one. Because remember, my heat sinks are L shaped, so that's the other end. That's the other heatsink mount there, and that goes all the way through to the side. And that's ground as well. That all this area is ground. That's where that box is. That's earth. Right, turn that over. Save it. I'll save the PCB one, because that's good. And possibly later today I might actually etch another board, because now I've got these new boards. I mean, not etch another board, I might silk screen another board, because I've got these wider boards, and I like the ability to make a board where I don't have bits missing off the edge of the board, you know what I mean? Because these newer boards, they are the right size. And when I made this board, I made it to fit those copper boards, but the bloody boards were smaller for some reason. I have no idea why. They must have got skimpy or something, and they must have just taken a millimetre off, thinking we wouldn't notice, but I noticed. Something else I wanted to do as well. I want to move the outline, the border outline. I want to move this in a bit, and I want to move the other one out a bit. That will mean that I'll be able to get my silk screen centered better, because my silk screens were slightly off on that top one. I'm not sure, let me see the bottom. That bottom one wants to be a bit further down. This is the board outline. Right, that one's a bit further down. I think that's about the same now. You know what? I think actually I should just leave that one on this side a bit further out actually. And that looks more equal actually now on both sides. Yeah. And I think that when you look at the purple area, that looks like it's a bit better, I think. What I'll do is I'll print this out on a piece of paper, on an ordinary piece of paper, and I'll just see if it fits this new copper board properly. So I'm going to do that now. I'm going to turn the printer on. I just want to test print. The whole point is to get the outlines so that when you turn them over, the board will. I'll put the camera on as well so I can see the actual printout when I've done it. It's so that when you turn it over, it still matches up everywhere. So I'll print that out. I'll just print stuff for a minute. Properties. I want vivid. I want to print all colours black. I want the bottom copper, bottom solder mask, bottom silk screen, board outline. Right, I'm just going to print this side. I'm going to print the other side as well. Then I can put the pieces of paper up against the light and see if everything lines up when I put the silk screen on the other side. So I'm also going to print the silk screen out, which is basically turn that off, turn that off, turn that off. I want top silk screen, and I want that. It wants to be mirrored. I think. Right, I'll just wait for that one to print as well. Right, I'll put the camera back on. I hope it hasn't made it giant. I hope it hasn't filled the screen. I might have set it to. Oh, let's have a look. Oh, it's alright. It's the right size. It's the right size. Right. This is just my inkjet I'm doing it on. I have to use the toner print, the laser printer for the actual board. But the laser, the toner is expensive, so I'm just using my inkjet for doing the tests on. I'm clicking on buttons for some reason. I don't know why I'm doing that. Accidentally. Right, this is the silk screen. I don't know if you can see it. Hang on a minute. Let me get my preview up. Right, I've got to cut this out, but actually no, I'll just hold it up to the light. I'll just, this is reverse, which is the way it's supposed to be. And this top one. I've got the wrong glasses on again. I need to get my my new glasses from the opticians. I haven't got them yet. Can't afford it yet. Yeah, that's the right way around. That's backwards too. So, because when it's backwards, it's right way when it's printed. So if I hold this up to the light, I should be able to overlap those board outlines, and all the components should line up. You can't really see it though, because it's difficult. Let me just see if you can see that. Now I've got this upside down. It wants to be, hang on. No, that was the right way round. That was actually the right way round. Bloody hell. Let's line them lines up again. Sorry. I'll get the border lined up, the board outline lined up again. I hope rust comes on. I wish I'm kind of getting rust withdrawal symptoms now. I have to go and see the doctor about some tablets. Doctor, I'm having rust withdrawal symptoms. What's that? What's rust withdrawal symptoms? I said, oh, I'm just used to watching rust on live stream, and you can't go on live stream anymore. So, yeah. Is there anything you can give me for it? Ooh, Russell tablets. Alright, I don't know. Actually, let me just put this light up a bit. Maybe you'll be able to see as well. I don't know. I don't know if you can see, but oh, maybe you can. I haven't got it quite lined up properly yet. But what you're actually seeing is what I'm seeing, and I haven't got it lined up the border yet. It's not easy getting this lined up when you're trying to do it on camera too. Let me just hang on a minute. When I get this lined up, I'm going to staple it because it's that hard to do. There's two capacitors. No, this is wrong. I've got the flipping thing wrong way around. Something is wrong here. Hang on. Those two capacitors. Oh, I know what I've done. I've got to put that way around. That's why it's not working. I've got to face the copper inwards. That's it. I've got it now. Just if I get these lines lined up. Yeah, I got it right now. Okay, let me staple this while I've got it. I think I've got it right. Just a minute. It's probably a fraction of a millimetre out of alignment. Right, I'm going to staple that. I'm going to staple it in more than 3 places. Well, 3 places should do it. Now hide. You should be able to see the tracks and the components. The components should shine through the paper. Let me get this light down a bit. You should be able to see the components shining through. I'm going to get it close enough together. I've stapled it so it can't move now. But there's a resistor there. The camera wants moving to the left, I think. Right, that's better. You should be able to see that. The components on the other side are shining through the paper where the tracks are. So if I get my pointy thing, and it won't move because I stapled it. This is why I need to get the board outline exactly right, so that when I line it up. So there's a resistor there, and another resistor there, and there's a trimmer pot. Oh, hang on, it's falling down. There's a trimmer pot here, and that's lined up with the pins. There's a transistor there. No, that's the regulator. The 2 transistors are over here, one there and one there, and they're perfectly lined up. That's the heatsink mount there. Right, I don't even see that. Yeah, there's a lag. There's another trimmer pot. So when I get the board outline, it goes all the way around, perfectly lined up with both board outlines on both layers, then all my components are lined up too. So that's good. That's all good, and I can see where the stapled in 3 places actually. The writing's back to front, but if I turn it the other way around, the writing should be the right way around. It is, but it's upside down now. Oh no, it wasn't, was it? Hard to read. No, the writing on one side is the right way around, the writing on the other side is upside down. Anyway, that's good. That's good. My smooth in there. So that's. I'm going to do this drill in a minute. Are you still there, Hyde? Yeah, that's all right. That's all correct. Because the writing's supposed to be backwards on the paper, because once it's printed onto the copper and the board, well, the circuit board, it's all the right way round. Yeah, that's right. Because if I had a piece of copper in between these two sheets of paper, and they were printed onto the copper and onto the fiberglass side, whatever, all that would be readable. Well, I can't complain about that. Just need to get a board like that, perfect. Because my actual board that I etched, you know, the one that I made, it lined up pretty well, but I'll show you what I mean. You'll notice that on one side of the board, I'll get the camera down a bit again, the holes that I drilled for the IC, they're slightly off alignment with the actual IC itself. You know, the silkscreen is slightly lower. The silkscreen is slightly lower than the holes because there was a slight misalignment. I didn't see that, but yeah, that's why I need to get the holes, the silkscreen bang on. You can see that with them diodes or A90s, they're actually a little bit off, a little bit out of alignment. Just a bit, not much. It's nothing really bad. It's just annoying when you don't get them quite lined up. By the way, you see, the funny thing is, it's right at this end of the board. Well, it seems to be better at this end of the board. Down here, I'm not sure why that happened. It might be something to do with maybe the size was slightly out, I don't know. But at this end of the board it was good, but then as we got further and further up to this end, it just kind of drifted off a bit, which is kind of strange. I probably didn't get my silkscreen on properly, that's probably what it is. Kind of drifted more and more as we got over here. But at least my silkscreen is still intact anyway. It's kind of difficult to see, really. You can see where I went wrong with my drill. I drilled two holes for Q4 and one was slightly off in the wrong place, but I had to re-drill Q4 one of the holes again, and you can see where I made that error. But it's alright, it's still good. I just basically drilled through the track. Let's see. You can actually see on this side. That gets lined up. Yeah, you can just about see where I drove through the track. Anyway, it's not a problem once it's soldered. It's right over to, I it's on the edge of the magnifying glass now. I need to get it back in alignment. Is it this way a bit? Yeah, you can just about make that out. Right in the middle now. I think we're right in the middle. Yeah. But you've got to admit this copper came out really well. I mean, the etching came out really well. I mean, that writing, the tiny little writing 2017. You can even read it. So I'm kind of excited actually to see what the next one will come out like when I get a proper piece of copper where I've not cropped my name off the top here. Yeah, because my name kind of got chopped off. Well, I put dual frequency signal generator, the very bit at the top, it got missed off because these boards were just a little bit too narrow, about 1 millimeter too narrow, which is kind of not much, but it was enough to mess up the edge of my board. It was either mess up that edge or lose my ground plane, which goes all the way around here, and I couldn't afford to lose that, so I thought, sod it. This end isn't critical because it's a real thick track anyway. This end has got a lot of copper running down there, and most of this copper is just ground anyway. And I thought, no, I'll sacrifice this edge to save this edge, you know. So I had to make a decision. Well, these new boards are going to be all right. I'm not going to have to worry about that. So if I look at my test print, right, and I put the board on it, you'll see, I'll move my mouse out of the way, you'll see that the board outline is considerably larger actually than the actual copper board. That's to allow me to get it dead center, because if the line is underneath the board you can't see it, so you have to have the line in such a position. For example, these little I don't know if you can see, oh actually the camera's probably too high again. For example, these, let me get my preview back up. Where are we? Right, these components at the bottom are right on the edge, right? These components at the bottom are pretty close to the edge, so I'm going to have this edge, this bottom of the board sitting right on the edge of that line, but the capacity, it doesn't matter if the part of the capacitor is off the edge of the board, as long as I get this in the middle. If I get this right in the middle, it doesn't matter if there's a bit of capacitor hanging off the edge of the board, but I don't want to sacrifice the writing if I can help it, you know. I want to try to get that for the next board. This board is a bit too small. Now let's look at a piece of board that's not too small. This piece of paper keeps wanting to move. Right. Let's get one of these boards out of here and see what's what. They're all wrapped up in cling film or something. Oh, actually I can pull one out. I've done this before. they're kind of sandwiched between a piece of plastic. It looks like they've cut this off while it's been wrapped actually. Getting one of these out is a bit fiddly. I've done it before though. Let's get my file. If I push one out from the middle I can do it. Right, one of these boards starting to come out the middle up, right. So I'll get my tweezers on here. I should be able to pull one out. Oh, can't quite get it. I'll just push it again with my file. I don't want to unwrap them all because they all come apart and air gets in and they start to oxidise, so I'm just going to pull one of these sheets out. Pliers, where's my pliers? Right, I'll pull one of these out. Come out, you bugger, come in. I just don't want to open them all because it lets the air in and they oxidise, so that's why I'm just pulling it out. There we go, I've got one out. And the rest of them are still wrapped up. Right, this is a new board. That is a lot bigger. Because look, my capacitors are not off the edge of the board when this is in the middle now. You can see that the line is on equally on each side. Oh, it's moved again. Right, looks like this is going to be a lot better. I think it's time for a coffee. Don't you agree, Hyde? Don't you think it's time for coffee? I mean, you can see how much wider that board is compared to my other board. If I stick this up against it, you can see it's wider. A lot better. I'll go read chat because I think you typed something, but I can't see it at the moment. But I've got the preview thing on. I've got to drill a hole actually, 2 holes. Now, I probably could do them now. Yeah, you read my mind. You said coffee as well. Oh my god. Yeah, I'm going to go and make coffee as well. I'll be back in a minute. be a minute, I'm just making coffee. Okay, right. I don't know if you're back yet. I wonder if this copper's actually thick on these newer boards as well. It looks like it's better quality actually. You know what? I think this copper's actually a bit thicker. Where's the magnifying glass gone? I put it somewhere. Oh, it's under here. It's under here. You know what? I think that this copper is better quality. Could be wrong. Let's have a look. You usually see the edge of the copper on the boards, but I don't know. Well, I can't really tell. The only way to do it, to measure that, is resistance. DC resistance. I don't think my meter's up to measuring that precisely, DC resistance of copper, but I'll give it a shot. It's actually got a coating on it or something. It reads 5, this other copper reads 5 ohms from one end to the other end. Just a minute, what's my meter read? 1.8, right, 1.8 when I short the probes. So there's a coating on here. Oh, it's reading 2. Hang on. It's reading 1.9 ohms from end to end. So that's 0.1 of an ohm from one end to the other. That's actually not very good. It means that the copper's pretty thin. What's my board measuring? Actually, I won't be as much copper there though. I've got 1.8 across between there and there. Well, that board's actually better. Hang on, this can't be very clean. Just a minute. I need to clean this new copper a little bit just to get a good reading. I want to find out if this copper is actually really thin, because it may be. I hate it when you get thin copper board. There's a bit of muck on it, that's for sure. Right, what's this read? Ah, it's reading 1.8 now. Okay, so it's not so bad. It's not so bad. It was just a bit of muck. I wasn't getting good contact. Alright. So that other board isn't so bad. I'll tell you what I could do. I could weigh. Ah, that's an idea. I've still got some of the old board, right? I still have some of the other board I ordered previously. I could weigh the old board and compare it to this new board, okay? We should be able to work out if there's more copper on the new board by the weight, because copper weighs a lot more than fiberglass, I can guarantee that. So if I put my scales on here, I'm going to get the other copper board from the bedroom. I want to compare them together. I just want to make sure I'm not getting cheaper crap, you know what I mean? Right, here is some copper board, which is, actually it says FR2 on it, FR4 on this one. And these new ones are the new ones are FR2. It says FR2. Right, the new stuff, it says FR2. Right, that's fiberglass resin number 2. Right. The previous ones I got were FR4. Right. So, what is the difference? What is the difference? That is the question. Right, scales. Right, I'm going to weigh one of these older, because I've still got some boards in here. I haven't used it all. I ordered some more simply because I wanted to make sure I didn't run out. Right, here's a board that hasn't been touched from the old stock, and that weighs 14.9 grams. Oh, you can't really see that. I don't know if you can see that. Maybe not. Magnifying glass, maybe you'll be able to see that. It's the light that's funny. The light's reflecting. Hang on. Move it onto the edge of the table. Right, you should be able to see that. I'll get this lined up properly. There you go. Right. This is old board stock. It's 14.9 grams, okay? Take the magnifying glass out, swap this board for the new stock that we've just received. And it's a lot shinier. And, oh yes, 14.3 grams. We are being ripped off. We have got less copper on this new stuff than there was on the old stuff. I thought it looked thinner. So this new stuff is 14.3 grams. Right, I'll swap it out for the old stock. Old stock. 14.9. New stock. 14.3. Yeah, what did he say to that, Hyde? I ought to complain, you know. I say, excuse me, but this copper is less than... oh, hang on a minute. Yeah, and this board, this new stock is even bigger, right? Don't forget there's an extra millimetre on it. This new stock is even bigger than the old stock. So how the hell can new stock that's bigger weigh less? Huh? So yeah, there's something not quite right there. I don't like it when we get ripped off, but at least it's a... Maybe they've given us bigger board, but they're actually giving us less copper. Yeah, that's weird, that. Huh. I'll just send them an email message about the fact that it's reading less. It's actually got less copper on it than the board's thinner as well. You know what? I think the board's actually thinner. It does say FR. It does say FR2 though, so it's obviously a different brand number. This is FR4, so that must be why. Maybe the 4 means 4 microns, and that's 2 microns. Maybe that's why. FR2 must mean 2 microns thick, and this was 4 microns thick, so this is twice as thick as that. Right. So, this copper actually looks kind of opaque compared to that one. I don't know. I'm just being a fussy bugger. This is the board I did some time ago. Actually, this is another one you haven't seen. I actually did this last year, 3 years ago. This is one I did on laser. About 3 years ago. It didn't even come out as well as the new one, because there were some bits missing on the transfers. But you can see it's been in mass storage, and it's still got the toner attached after 3 years. I've never etched this board, but look at the detail. Look at the detail of that writing, right? That writing, look how big my finger is. Right. Now, look at it under a magnifying glass and you'll see what I mean. Where's my magnifying glass going again? Right. Now, oops, I'm looking at the camera. Now, look at that for detail. Oh, it's upside down. Hang on. Right, look at the detail of that writing. Got my name on it, Shelley at the bottom. It'd be better if I get this angled right, I think. Right, can you see that hide? Can you see how small that writing is? Next to my finger. And you can actually read it. When did I do it? It says October 2015. That one. You need a magnifying glass to read it. Maybe I ought to go into the what do you call it business? Microfiche business, microphone business, making miniaturized books for Schubers to read. Oh, that'd be funny, wouldn't it? I'll tell you something, I could not do that by hand. I could not make writing that small by hand. No way. Absolutely no chance. Yeah, I got some more copy as well, but I'm going to drill them holes now, and right. Oh, I'm going to leave this board out because I'm going to clean this copper up later, because I want to etch another board. So it doesn't matter if it gets mucky. I need to drill 2 holes, and look at the size of the drill is 0.3 millimeters. This hang on. This drill is 0.3 millimeters in size. Hang on, I can't even see the preview right now. Right. I don't know if you can see it. It's so tiny. That's the drill I've got in right now. It's very tiny. I could break it, but I've got a whole pack of 10 or something, and it's running true. I've just got 2 holes to drill really, but right, let's see if it works. Oops. Camera's not pointing at the right place. Where is it? Down here somewhere. What do we do here? So right, I need my magnifying glass to see the damn drill. I just wanted to test it out. This is all I'm doing it for really. Oh god, it's sharp. Hey, that's brilliant. That is really sharp. That drill is really, really sharp. Now I'm just going to get my magnifying glass and show you what I just drove. I'm not going to blow the dust off so you can see where it is. That's where I just drilled there. You should be able to see light through there actually. If I can get a light to shine through those 2 little holes. I left the dust on purpose so you could see where I drilled it. I can't really. Hang on. Well, I might have to blow the dust. Hang on, I'm going to blow the dust off. Now you should be able to see through it. God, those holes are so tiny. And you're saying, are you sure you can get a capacitor in there? No, I am. I just wanted to make sure that I could drill a 0.3 millimeter hole. But let me just find out actually, capacitor. Can I get a capacitor in those holes? Right, okay, look, I've got a capacitor, it's electrolytic actually. Can we get these legs in those 0.3 millimeter holes? I've lost the damn thing now, where is it? Oh, there it is, right. It's here, this one here. It's like threading a needle. Oh, it's going in. No, not quite. Jesus, these holes are so tiny. I think this capacitor's legs are actually bigger than 0.3 millimeters. Yeah, they are. The capacitor legs are even bigger than the drill, so they won't go in. Let's try this side actually, just to make sure. Yeah, this capacitor will not thread in that hole. Now let's find something that will. Well, these are massive. There's no way they're going to fit. Hang on, I'll check chat. Hang on. Well, at least I can drill 0.3mm holes, even though I can't put anything in the holes. The point is, it helps me to get things started. There are components that have thin legs, though. I have some capacitors somewhere that have extremely thin legs, you know. But I'm not sure where they are. Oh, I know where they are. I know where they are. Just a minute. I think I remember now. Aha, I know where they are. Right. They're in this box. I think they're in here. There are some transistors as well that have got very thin legs. Usually it's the polystyrene capacitors, these, hang on, that have very, very thin legs. Now this is a polystyrene capacitor that's broken, there's a leg missing on it, but that should fit in that hole. I want the preview back up. Can't see if you can see. Right, okay, right. Where was it? I've lost it now. Where the hell is it? Oh, it's over here. Right. That's the one there. Does this fit? I think it will when I find the hole. This leg is cockeyed as anything. It might help if I get the magnifying glass, and I can also look on the screen, because I can see on the screen actually better than I can see down here. Okay, I don't know if that's actually showing up. Where has it gone? I've lost it now. There it is. Here. Right, it's that oval shape thing. Oops, sorry. I can't see what I'm doing. so small. These legs are very thin, they should go in the hole. Just a minute. Is the end? Oh, the end's bent slightly. That's why I can't get it in. It's got a little kink on the end. Well, I'm going to, it might have a blob of solder on, so what I'll do is I'll cut the end off. Ah! My knuckles were cracked then. Right, this should go in now. The magnifying glass has moved. Right, it's that one here. You know what? I think the hole's blocked up with me. Ah, it's in. I've got it in. Just need to lift this up to get it through. You know what? I think the hole is bunged up. Just a minute. I need to clean it out again. Right. That's really sharp. I almost went and drilled another hole. I'm really prying about right now, just testing these drills. The legs are so thin they just bend. Hang on a minute. I'm going to try it from the copper side under my light because I can't really see what I'm doing. Holy moly, that is so... the capacitor just fell off the leg. The leg is in the board, but the capacitor is not on the board. That was so funny. The leg, just I twisted the leg in and it came out the capacitor and it's stuck in the board now, look. Don't know if you can see it. The leg has gone in the hole. But minus capacitor, because these are so old. I have to chuck that in the bin now because it had it. But at least it went in the hole. Yeah, I've got a whole bunch of these polystyrene capacitors. Some of them have got thicker legs and others. They're actually kind of vintage, these things. Yeah, most of these the legs are too thick. I think I've just destroyed the only one that had thin legs. Oh no, that one's got thin legs. This one's got tiny little legs as well. These are old. I mean, they were taken out of something. Anyway, I'm not going to destroy it. I might need it someday. But at least I know that the controls work. And I'm going to eat a pot pie now. Oh, not a pot pie. Egg and bacon pie. drink some coffee and have a think. What was I going to look at? I was going to look at something. Oh yeah. I'll put my other glasses back on. Well, I'm happy that that drill works, because as I said before, I could not get 0.3mm drills in this chuck, and they would slip and skid, and they just wouldn't work, and now they do. So that is a huge bonus, that I can actually, even though I've ordered some new chucks, according to the online information on the new collets that I've ordered, they fit 0.5mm up to 3mm. Well, I needed to be able to use 0.3mm, and now I can if I need to, which is what I wanted, because I've got a whole stack of 0.3mm ones in here, and they didn't cost me much really. But they'll be very handy in certain situations, because there's situations when you need a very small hole, usually because the pads have been made too small, and you need a centering drill. And what I mean is a drill that you can get right in the middle of the pad to center it and drill it, and then you could use a slightly bigger drill to drill into the center, because it stops the drill from wandering off course and destroying the pad. That's why a centering drill is really handy, and those 0.3mm are exactly that really, just to help me get right in the middle, as well as for small components if I need them. When I eat my pie, then I'm going to start, well, I'll start working on that, on a new photo printout. I mean, I could build this one if I wanted to, but I want to do it on a bigger board. I've got this one just like that, you know, that other one, that, you know, the other one, sorry, I was going to go on the, I'm just talking really, I'm not really showing much. Oh, it's AT. Oh, hi AT. Well, I feel good because I didn't beat anybody today. Wow. And my IC socket fits like a glove, even though I took 2 pins out of it. Where's pin 1? Pin 1 down there. Fits like a glove. Doesn't fall out when you turn it upside down either. I took 2 pins out for where the compensation was. You can easily take the pins out on these, which is really handy. But, yeah, I'm not going to waste a socket in this board anyway. I can use it in the other board that I'll make. This is my apple and bacon and egg pie. It's a mini pie. It's a mini pie. I don't want to make anybody hungry, but yeah, I just thought I'd show you what I got from the local market. It's yummy. I can't get it out the flipping aluminium. If I can get it out of the flipping aluminium packaging. I hate it when it's stuck to the flipping aluminium. It's a problem. Oh, there we go, got it. Yum, yum, yum. This is British egg and bacon pie, miniature one. I could have got a big one, but I never eat them all. They always end up, half of it ends up in the bin, so I thought I'd get a small one. That can go in the bin now. That foil. So what was I going to do while I was looking at this board? I'll just go to the screen a minute. I think that board is actually completed, including switch now. I'm just waiting for some switches to arrive. Alan didn't understand why I was putting a short link on the track directly across the switch. He said, well, what, if you're going to put a track there, what do you want a switch for? I explained to him, I said, well, sometimes you don't have a switch, so you want a connection to be made, and a lot of the old TVs in the years ago used to have a track that you could cut to modify the board, you know. It was a common practice back in the 70s, even the 80s actually, to have even now they do it, but you basically have a weak point built into the board, right, which is what that track is. Oops. And when you don't have the switch, it's already always connected. And when you want to use a switch, you simply cut the track and put a switch in its place, and then you've got a switch, and then it saves you putting jumpers and things like that across wire links and hacking the board in that other way. It's a lot easier to do it this way. I used to repair TVs back in the late 70s and 80s as a hobby really, but I often found TV chassis and you'd see where somebody cut some track and you think, oh, and it was a modification that they'd done. I think I've got everything modified that I want modifying now. What I am thinking though is it possible to make that border a bit narrower actually, but don't know. Maybe. Nah, I won't bother. Not worth it. Considering the new boards I've got are actually bigger. Mm. Well, I could make a bit more of a gap there. Which capacitor is that anyway? I've forgotten. Oh, it's next to the mount, the thingamajig. So it will be. Oh yeah. I could move that a little bit. Yeah, on that one. Alright, that's better. I didn't like the close proximity because you can get a short circuit with a blob of solder across there. That might be better. Yeah. Oh. That's the optional thing, I think. Yeah. It's not even going to be in there. Oops. Keep zooming in too much. Oh, that track could be thicker. Let's see. Check hours. Oh, now I've got flipping errors. Where the hell are they? Oh, not here, are they? Oh, one of them is. Oh, undo that. Oh, bugger it. Just change that to smaller size. Oh. Where the hell have they come from? Hang on a minute. Go to... Oh, it's because I moved the board outline. That's all. Well, that's right. So maybe it wants me to make that track a bit thinner or something. Let's find out what size it is. Hang on. I can't. What's that? I can't see the bloody bottom of the back. Is that properties or what? I can't see it. Stupid program. Oh, Jesus, I can't get to the bottom menu. View. Properties. Oh, that's not it. I can't get to the bloody thing now. What's going on with this? The menu is going right at the bottom of the screen and I can't get to it. Believe this. Hang on, move that smaller. Oh, now I can. Right, what thickness is that? Width is 5. I'll make it 4. That should be enough. Try that. I don't want to move the board outline because that looks right. Now where is it? Oh God, here? Why? Because I've got a track there. This is silly. Move that up here. Right. Okay. Looks like everything's good now. Oh, see a problem there. I don't believe this. Just because I moved it a little bit. Oh. Right, try again. Okay, thank you. No more errors. Jesus. Yeah, I'm going to kill the stream hide anyway. But in a few hours, when there's a few people awake, I'll probably start on this other new board version, which is version actually it's version 8 actually. I printed it on the board. Revision 8. Of course, I've only printed the only other board I've printed out. The only other board I've etched up to now is the after the first one. That is it revision 6? Yeah, the one before that was revision. The one that I've just been drilling is revision 6, and the only reason I put a revised number on is to keep track of things, so that if at some point in the future I'm looking for the latest board that I made, I'll think, oh, which one is that? It's always handy to have a number somewhere on it. Good. I actually need to print this out as well. I need to print out a new schematic actually while my printer's on. Oh, I hope I set it to landscape. No, I didn't. Oh, damn it. I'm going to have to put them bits of paper back in again. I just wasted 2 sheets of paper for the sake of 1. Oh well, I'll put the paper back in, so I'm using it again. Can I do a print preview? No, I can't. Should be right. What the hell? It's printing 2 again. Why? It should fit on the page. I don't get this. Why is it? It usually fits on the page, so what I've done wrong. Print setup should show me where it is. I know what I've done. I made the sheet bigger, didn't I? Aha, that's what I did. Oops. I need to move this back up again. Oh God, I can't get to it now. Zoom out. That's wrong. That should be right. Move it back up, and that's probably why it's. Right. Oh yeah, it's still printing. Oh, that's what it's doing. some reason. I don't know why it's done that. What I'll do is I'll print a PDF or something first and have a look to see if it's one page. Let's have a look. Have a look, see if it's one page on the PDF. Oh, I could set the size a bit smaller. Let's just try it with PDF. How big is that? Is that one page? It is now. Right, try again. It says one of two pages. Bit plot, right. Oh, that's why. 146%. Ah, okay, that's the one. Ah, should come out right now. Yay, I think so. Oh, that's better. All in one sheet now. Okay, exit. think I want to kill the stream actually. Well, my printout came out really well. We're all on one sheet again, which is what it's supposed to be. I don't like schematics that spread across multiple pages. It's like a jigsaw puzzle. Schubert is here! Never fear! Schubert is here! Oh, what is it? What day is it today? Hang on. ABC. I think it's a poodle day. Oh, I wasn't even in the box. I think it's a poodle day. I sense it's a poodle day. I'm psychic, I told you. Yeah, I just pulled out the ether. It is a poodle day. A damp, wet poodle day because it's raining outside. Yeah, I'm giving poodle readings now. Yeah, bring your poodle to me. I'll give him. I'll read his paws. So I've got my 0.3mm drill bit working, and I got some new circuit board in the mail today, Hubers. I don't know if you're watching. You must be, because you said it was raining, so you must have heard me. Anyway, these new boards are actually slightly wider, which is even better because it means I can get more of my silk screen on. So extra millimetre. An extra millimetre. God, aren't they generous? Anyway, yeah, I'm not doing much right now. So I'm probably gonna stop the stream for a bit. Oh, by the way, the plug's fit alright. I'll show you. You know what problem I had before? Where the plugs were too close. Do you remember Hyde? You remember how they were too close? Well, look now. Perfect. Hang on, where's the one? Where's the other bag? I need 2 plugs again. Right. 2 2 plugs. Look at that. Perfecto. Can you actually see that? Oh, can't tell. Anyway, they fit now. Actually, one looks a bit higher than the other. That's probably because of the way I've drilled it. Oh yeah, I need to drill that. I need to drill that hole a bit low on this side. Oh, a bit higher on this side. Okay. But the plugs actually fit without being obscured. Capacitors go on the top. Wire entries is this side and on this side. So yeah, wire entry is this side and this side, and capacitors there. Transistors, power transistors there. Heatsink goes between them without any problem. I think I think I'm going to drill them holes a bit further though. Hang on. That's all that. I made slotted holes, you see, but I haven't drilled them slotted yet. I'm eating some bonbons, by the way. Oh, more pyramids. I don't know, I seem to be hearing a lot about pyramids just lately. Don't know why. Another reason why I don't want to build this board right now is because I'm running out of sockets and I don't want to use all my parts up on this board when I can make another one right now. So let's put this big drill in and make them slots a bit better. If I can, I've dropped the thing on the floor now. I've got the wrong glasses on again. Sure was as bad as me. He keeps designing things. I can't get this drill in here now. I've nipped that brass. I nipped the collet up so much I can't get the drill in. Well, it'd be good when the other collets arrive because they're all different sizes. Oh, that's going to work. Anyway, the hole's already cut, so I just have to make that hole slotted more. So, let's see. This one... should be able to tell by the silk screen anyway. I just want to check first. Yeah, the holes want to be a little bit more this way. See if these fit more straight. Like gonna do. Oh yeah, that's better. Good. So I don't need to make no changes to my schematic or PCB design, because the holes are fine, it's just I drilled them slightly off before. Now I've drilled them right, you can see they line up perfectly. Oops, I can't put it down flat because it pushed the pins up. Oh, knocking the camera, put my pliers down, then I can rest it on there. Oops. Well, I thought I could, but yeah, that's it. So they do line up properly now. Will do when I've soldered them in. So much better that. So I don't know if you're watching Hyde, but these new arrangements for these pins are perfect. These sockets, they're actually just bang on now. Get my ruler. Yeah, they're bang on. When they're soldered, they'll be straight. I'll solder them so they're nice and straight. Not in this board, but in the next one I do. Because I'm running out of these sockets, I am. I'm probably going to have to at some point, because I have loads of bigger blue sockets. The pins are just slightly further apart. So what I could do, because these are connected to the ground rail, I could actually technically use these blue ones anyway. Let's see if these blue ones will fit in the holes. If they don't, I'm gonna, because these are heavier duty, I would like to use the blue ones. Now I won't have to use all my little grey ones. Oh, they are kind of grey. But as I say, I'm not going to put them on this board because I'm going to run out of components. I'm going to make another board with the switch on. But I'm just using this board right now to check everything. Now let's see if these blue ones will fit. Well, not yet, but they will fit if I do another hole next to the big hole. Because the other hole is on ground, right? That means that all of this area is ground, which means I can easily drill another hole next to these holes, and I can use either the small grey sockets or I can use the large blue sockets. I'm reading. Oh, Rusty's there, yeah. Right. So what I'm going to do now is I'm going to drill another big hole next to these big holes. Then I can use these blue sockets, and there's still room. There is still room. They're not going to obscure the heat sink. The heat sink is still going to run past them without any problem. Right, so I'm going to drill those holes now, and I'm going to dimple the copper because that way I won't drift around. Yeah, Rusty's at work. Yeah, cool. But I wish we could hear him. I wish he'd come on. I'm going to take this socket out a minute. I need to put some dimples. Actually, it'd be best if I do it Markham with this next to it. So if I look at that, I can see where it needs to go. It's right there. Alright. Put a dimple right there. Actually, that dimple is a little bit off, but it wants to be next to that. I'm doing it like this because every time I push down on this compass, it pushes the pin out. There's a little pin in there, and it pushes the bloody pin out, so I have to wiggle it. I could just dimple that there. Right, that should keep my drill centered, and I can put the blue ones in then. I won't have to use all the black ones up. Oh, there's one problem. This drill bit wobbles. I'm just thinking, actually. Ooh. Now I'm going to have to use a smaller drill to start that off. So I'm going to take this big drill out a minute because it's wobbling too much. Find this tiny little drill. Let's see. Maybe that one. Maybe this one. That drill should work. Yeah, well, I'll try it. I need to close my collet up a bit more. I'm hearing noises. Something like clunk. I don't know what that was. I've got Ghost. The Ghost of Christmas Past. Oh, this one's wobbly too. Hang on. But the little drills bend more, so they don't cause much of a problem when they're wobbly. The big ones tend to cut wherever they go. Those chucks, those collets should be here soon anyway. That one's still wobbly. I'm trying to get it in straight. Like that. Oh, that'll work. That'll work. Yeah, I've got it. Right. I think that's going to work. If it'll stay in that dimple, I'll be fine. Yes, I mean, next dimple. And yeah. Okay, I've got my starter holes made. I'll put the bigger drill back in. This is a lot of messing about because of a bad collet. Right, is this straight-ish? I actually snapped one of my drill shanks off earlier, but I could still use a drill because it was just the tip of it that I broke off. It was kind of funny. Right, this should work because I've already started a drill hole through there. Okay, now I can get the blue ones in. It's a good thing I've got a large ground plane over there, it really is. And I should have a countersink somewhere that I could just take that burr off. Somewhere. Might have rolled away. Where's my countersinky thing gone? It's probably in here. Tweezers. That's not the one. Oh, is that it? No, that's not it. Where's the flipping countersink gone? I don't need the countersink, but it's probably on here. Oh, it might be on the floor actually. It's probably rolled off. Oh, it's not underneath here. Some things do. Oh, I see it. It's over here. Right. I'm just going to use it by hand. Just twist by hand, just take that burr off. Like I said, I'm not building this board, I'm just basically practicing. But it's ready if I want to build it. Because I'm going to make another one. Right, see, this should fit now. Yes, it fits perfect. The blue ones fit now. Now, does the blue one fit on this side, and is it straight? Yes, it is. Which means I can do the same thing with the next board, which I'm going to be doing later, with this wider copper board, which means that my plug won't be right on the edge like it is right now. Yeah. Oh, I've got that socket facing inwards. It wants to be facing outwards. Oh, that wants to be facing outwards as well. Yeah. Like that. There we go. And I can read the writing in the middle. There's some writing, but it's right down the middle. I can read AC and ground. There's some writing right in the middle of these sockets, right? At the top it says AC, at the bottom it says ground. I can even read the flipping writing. Wow! How cool is that for getting the text in the right place? Of course you can't, because it's a bit dark. It's got a big shadow over the two plugs, but trust me, I can read the writing on the wall. Yeah. Yay! And I've got a bit of play to move them around a bit. The holes are just a little tad too big, which is better than too small, because you can position the components and solder them. You know these plugs? Yeah, you can actually stack them, you know. You can actually push them together like this. Oh, I think you can. You're supposed to be able to snap them together. You're supposed to be able to slide them to be able to. There you go. Like that. You can actually stack them to make bars if you want to. But I don't want to, so. Oh, can't get it apart now. Oops. What have I done? What have I done? I can't get it apart. Oh, thank God for that. For a minute there, I thought it had interlocked permanently. I was just being humorous. Yeah, cool, Ross. Yeah, I'm going to stop the stream. Oh my God, I'm going to stop the stream. I'm going to stop the stream. It's at 2 hours and 59. It's going to restart otherwise. Right.